All right. Hi guys. So I'm gonna try to do a kind of a walkthrough of the material in chapter 7, which is the idea is the distribution of sample means. Um so basically the way that this works is you want your we are figuring out a way to compare the likelihood of creating a particular mean, a particular average for a group, and seeing how well does the group and its average that we came up with, how well does it compare probability wise to all the other averages that could be or that could have been generated as well. Um, we talked about the idea of sampling error before. Um, how two different samples can have different um, descriptive stats to them. Um, like if you have a group of 20 and you can only select a group of 4 or 5 each time, how each group 4 or 5 out of those possible 20s, they might have, some differences in and of themselves. So the question then is, how well do they, how well does the sample average that we found, how well does it actually compare to the actual average of the larger population that we drew from? Um, okay, so basically, uh, the way that this gets broken down, um, is you figure out a way to calculate out calculate out all of the possible averages that could have occurred, and then seeing what is the likelihood of each one being made. This is just when the sheet of notes that I was going to hold, and you know if we were meeting as regular. But basically, um, this is an example of just a very small. Let's say you're only have two subjects to work with, or two possibilities. This being um, two ping pong balls with either the number 0 written on it or a number 2 on the other one. So the first time we pick it out, there's a 50-50 shot of it being a 0 or a 2. This case, it's a 0. This time, it's a 0 again. So the average of those two just comes to 0. First is 0, second is a 2. The average of that is 1. The first time, and then, right, so you see what I mean? You average them out, and then you create just a simple distribution of those possible sample means and how often did they get picked or did they get generated. This is a very basic, but then your text just made a bigger one. The basic idea of you have uh like the one over there, two selections that you can make. This one said that it's of this, you can have a 2, a 4, a 6, or an 8. And you're drawing 2 from it. So this breaks down all of the different possible ways of selecting. And then this information here gets transcribed down to the distribution. And as you can see, as we've talked about before, that normal curve. Now, what this means is that the generation of the sample mean of 5 is the best fit. It is the actual mean of all of this going on. And 1, 2, 3, 4 times has the possibility of being made. So let's see, there's 16 possible samples. So in this case, there is a 4 out of 16 chance, so a quarter of a chance, that the actual true population mean will get generated inside of the sample. Overall, there's a 4 out of 16, but technically for each time you do it, there's only a 1 out of a 16 because you can only do one sample at a time. So this is basically just a way of giving us a analytical tool of figuring out what are all the possible sample averages that could have been generated, given the parameters that we are working with or starting with. Let's see. The expected value of m, it is exactly as it says. It's what you would expect the value of the larger overall mean average to be. So that's just a term. Okay, this is the other meat and potato part of this chunk of material. So we've talked about standard deviation in the past, and standard deviation is the, on average, how much will the group average from each other. So standard deviation is a measure of variability, how much variability is going on inside of our group. Standard error then is the same idea of variability, but for how much variability is going on within our sample means. As you can see, basically we are taking, to find the standard error. Okay, so conceptually, standard error how much on average the different samples means should differ from each other. And the formula for that, so it's the same symbol as standard deviation, but then with the subscript m, is taking the standard deviation of the group that we're working with, and you guys know how to calculate that as far as just when you are working with your group, and then it's divided by the square root of n. This part feeds into the idea of we have to take into consideration how big our group size is as we compare it against other groups potentially that big as well. So if you think about it, standard deviation divided by the square root of the group size. If we had a group of 10, so let's say we know we have a standard deviation of 1. If we had an n of 1 versus an n of 10, it would be 1 over 10 versus 1 over 100. Sorry. Which one's bigger? Which one's smaller? The smaller one is this. It's 1 over 10. 1 over, what is that, like 2.7? Hold on. Kind of curious. What is the square root of 10? 3.16. So 1 over 3.16 versus 1 over 10. This is smaller. Okay, so as the n goes up, I'm really bad at this, I'm sorry. As n goes up, this gets, as the denominator gets larger, the overall fraction is smaller, 1/10 versus 1/100. Basically what that means is as our group size gets bigger, we should actually expect that group to have a smaller variance of the true mean, because the more people you have in a group, the closer it is to a population, right? As your sample gets bigger and bigger, the window of difference, so to speak, to its actual population gets smaller. So how much? So what standard error is? Standard error comes up later when we talk about doing like t-tests and shit, when we don't know information about the population. Like say we're trying, let's see, I was going to try to do a coronavirus reference just because, but so let's say we're trying to figure out how to make a new vaccine for this. Never mind. This corona thing is ridiculous. Basically, when we don't have information about the population, we have to then get more information from our sample to represent the population in question. Sure. Let's say we came out with a vaccine that we think would be more effective for, let's say, kids versus adults. So we would test it against kids versus adults, but we don't know what would be, if we quantified getting better data, so to speak, we don't have a population directly representing that. So we would just have to work with the information that we have about our sample to determine if it would be a close fit of the population it's trying to represent. Okay, sorry. Okay. So distribution of the sample means how much on average, or what is the likelihood of picking one over another, or generating one over the other. Standard error, because I don't think you actually use this equation in any of these, so to speak. Like, it asks you how to find it. Oh wait, here we go. So the z-score, let's do one of these. Okay. Population has a mean, population mean of 80. The standard deviation of 10. No, 12, sorry. And we're asked to find z-score. Oh, right. Okay, so this helps because if you find the z-score, then you can do all that proportion and probability stuff from the area under the curve that we talked about before. Like if you know the z is negative 1.75, how many people are below it, that versus how many people are above it, sort of a thing. So this is saying if we know we are working with a population mean of 80, a standard deviation of 12, find the z-score. And the first one says where there's a mean of 84, your sample mean is 84, and you have 9 scores. Nice. Yeah, these will be good. So z equals, sorry, the mean minus the mu divided by standard error. Okay. And standard error equals standard deviation divided by the square root of n. Okay. -80 minus 84. This equals out to be, standard deviation is 12, and we're working with the square root, or we're working with a group of 9. So 12 square root of 9, so 12 over 3 gives us 4. Sorry, wow. I might need to try something different. But anyway, so 80 over 84 divided by 4 equals 1. Alright, I'll try to have this be done in the next couple minutes. So we have a z of 1. Okay, so what that means is in the given world of the parameter, a population mean of 80 and a standard deviation of 12, if we worked with this population, came up with a sample of this kind of info, 9 people, and they average out to being 84, they would be a z of 1, their mean. So their mean is right here. That doesn't make sense. It said negative 1. Well, so that well, that should work. Hold on, let me think. Okay, sorry. I realize we can't Do you remember in class when we took two different distributions and then put them into one? Like if this is one here, how would it be over there? Okay. So the other samples or sample problems, exercise problems, is using these other sample information from that given population. Now remember, so you're working with different n sizes each time. So what I was getting mixed up in is why wasn't this working over here? Because I was like, I thought for a second it was supposed to, come like that and work, but that's this, what I was starting to draw, this is the population info. This here is saying if you were to be working with groups of 9 people, okay, groups of 9 people, and you got an 84 that time. In the sample parameter, so to speak, of only working with 9 people, a mean of 84 would be a z-score from this info here. So yeah. Like if you did the boxes for every one, but with a group of 9, an 84 in that setup would be a z-score of -1. Sorry. See, this is why I need to teach in person, so that I can... Sorry, I'm trying to be myself without you actually being here and pretending that you are, so it's just kind of weird in the head, so to speak. Okay, let's start with that, and email me any questions, you guys. I'll extend the the deadline for the first exam. I'll extend it to a week from today. If I have no idea if that was just like completely worthless or if it was helpful, and I apologize. But if I can create or email me or like a discussion board or something, yeah. I was gonna say if this seemed completely unnecessary, or, well, I will keep trying to do better. This is my first time doing this, so can only hopefully get better from here. Okay. Hope you guys are doing well. Shoot me an email, and I will try this again soon. Okay.